Hey everyone, this is Marcus. Welcome to another episode of the Graph Builders Office Hours. We have the ETHGlobal Istanbul winner of the Best Substreams team here, the Nazar team. We've got Arseni, Armin, and Tomas here today to present their build of the winning Substreams build using Substreams. So welcome the Nazar team, and go ahead, Amin, and take it away. Great to have you here today.
Thank you so much. Hello, everybody. Nice to see everybody. Today we're presenting the hack that we did in Istanbul. So Arseni, Thomas, and myself. I'll just try to put my screen back. And to put some names on the faces. So the team that we were working on the Nazar hack is Arseni, who's also has his camera, and then we have Thomas. Gary couldn't sadly join us this day, and myself. And what we tried to build actually in ETH Istanbul is something that we had ourselves in ETH Paris, and we saw many builders have the same problem, which is you hear account abstraction and you say, amazing, this is super nice, I want to start using it. But the moment you start building actually on top of account abstraction, then you discover that transactions became way more complicated, that now making a transaction is not just an address, a wallet address in EUA, sending a transaction to a contract. It's actually so many components that are participating in the transaction, and you don't know which one is which and which one are you using, and if an error happens in which component. And if you want to look at the traces, how can I see them? And many questions come to your mind. And if you go to the block explorer, what you see, it's handle ops. Good. Yeah, it's an account abstraction transaction. And it shows you some addresses and it shows you some logs and stuff. But it doesn't give you the information where the error happened, which paymaster was used here, which bundler, how much did the bundler make actually. And to do this, we needed to do two things. So the first one is to start indexing data from the chain to get the transactions and to know this is actually an account abstraction transaction. And we added also the safe transaction, since they are the OGs of account abstraction in another way, in another flavor, I'd say. And we said, yeah, we have to start index all of them. And once we did that, we decided, okay, we can actually now make some conversation around the transactions. And if a transaction is actually a malicious transaction, to start finding similar ones. And this is the second thing we wanted to do. And maybe to give you a small demo to show you how the whole thing works. So the Nazar application was a simple application that we did, that you can paste transaction hash, or you can see this list here. This list is a substream that we're using to actually index all of the safe and account abstraction transactions. Whenever we find one, we say this is one. We put it in a database that we are showing here from the UI. So I just choose one of them as an example. So when you navigate there, what we do, we go deeper into the transaction and we show you. So the things that I said. So how much did the bundler actually make or lose? How much were the fees, if the transaction is successful or not? Who's the bundler address itself? Who is the entry point that was used actually? If there was, this transaction doesn't have a paymaster. If there was a paymaster, we will show you the paymaster and all of that. And we went over, also showed you also the transaction flow, how the transaction look like actually, that that's the anatomy of the transaction and how complex the transaction is. And in addition to that, we did something with using Wallet Connect, that you can subscribe to transactions and have a notification center that tells you, okay, you subscribe to get similar transactions to that one. So those transactions, if it's a malicious transaction, as I said as an example, then you get a notification and you know that, okay, other transactions similar to it happen, and you can go and look at them. And this was the hack that we did and worked well. But we did something more interesting that we wanted to actually include it in the project that we're working on. So BlockTorch is the product we're working on all together. We decided to actually take that, and we said, let's bring it to production and make a real product out of it, not just a hack. And that's basically what we did with BlockTorch. In BlockTorch, we just made it look much nicer. now the table is the stream, and you can see like other chains that we could get also, and we integrated all of them. And the interesting thing that started happening is how can we bring the hack to production? Arseny will tell you more about it, since we did many things to make it happen. And also once we start also doing like the substreams, how we can make like everything super fast and looking like showing like everything really fast for you, that when you navigate, you don't see like a problem, you don't wait a lot. And these are like all things that we worked on in production, and we added like more things here. So go try into the tour. You will see that we added now stack traces, since people start asking us to add stack traces. We improved our visualization a bit. We added also metrics. I have to create an account to see them. And we added many things actually to the hack to make it a production ready thing. So basically this is our hack. This is the problem that we worked on. But the interesting thing is the substream. So how do they look like? What did we build to make this whole thing happen? And this is something that Arseny can talk more about.
Yep. And it's me. So yeah, with the upstreams, we did quite a lot of interesting things. And actually the last thing that Amin showed you, like this beautiful stream on the Blockdash website, where you can see all the recent account obstruction transactions, are the ones that is like powered by Substreams, and it's being retrieved. Like all these transactions are actually done by using the filtering and transformations that we do with the Substreams. So just to get a bit into some more technical details, we can show you some of the code snippets. So I mean, if you can click on the right one to the manifest extract, yes, this one. So this one is basically something that I think majority of people here already are familiar with. It's not if people used only subgraphs like non-substreams, it's more or less similar. So it's the manifest where you can define what exactly what kind of handlers is your project using for index the data, the blockchain data. And you can see like the main module here that I just put into the screenshot is basically the filter account obstruction transactions, which receives the Ethereum block of type type that has been produced by Firehose of streaming fast, and then we are producing. This model is basically producing the output, our own defined protobuff definition, which is actually just referring to account obstruction transactions. So, and now if you show the left screenshot on the left, yeah, this one is basically the main module that I already just told you about, where the filtering actually happens. We can see that we are loading the chain name and like the needed addresses that we need to track. For example, for the standard JS3 4.7 entry point, and for the safe transactions, it's a set of addresses that we are tracking in order to see to be able to filter out the transactions which are happening with the smart accounts. So we can see that you can see that we are composing the filters from based on this data, and then we're just simply going through the block transactions. And in case that there is the filter that returns us the data about the account obstruction transaction, where we use some of the matching, which we'll also show a bit later, we simply just creating the transaction object out of it, adding, for example, which type of the account obstruction transaction is it? Is it like ERC4347, or if it's like the safe transaction? And then we're just creating this transaction for all of those who actually pass the filtering. And one of the examples of the filtering is below this screenshot, not this one, below here. So here's like some of the examples. We use much more of the matching, but this is, for example, the something that we can use to filter out all the needed handle ops transactions. So basically, if some of you know, there's like entry point contract usually handles the smart account transactions, which always have like the function being called, which is called handle ops, and we basically match and decode this one with the help of Substreams. It's done pretty easily. We just need to check if this is working or not, and if, for example, this filter works, we return true, and if it fails, we return false, and that's how we filter out the transactions. There's like more logic into it, but that's like one of the examples how to one of the filters that we use in order to get correctly like all the needed transactions. So that's basically how we track the account abstraction transactions, and we can show you now the other substreams that we also did like during the hackathon. It's something that also Amin mentioned. It was about the similar transactions. So if you remember, as I said, like we are tracking some exact contracts, for example, entry points or the safe implementations. But then in this substream, which is a different one, we don't need to track any particular contracts. All we need to do is we need to go through all the transactions inside basically every block. And the only thing we do, we are skipping the transactions to address that we, for example, know that we saved its original contract and we want to find only similar transactions to this contract. So we are skipping this one, and then we apply the special call signatures pattern where we can actually find, by which we actually find the transactions which are similar to the original one, but not exactly this transaction. That's how, for example, we can find, in this exact case, we are looking for the similar ERC-4347 transactions happening to another entry point. So let's say there's like multiple versions of entry points on the main node, and there also like some people just testing out things with entry point contracts by themselves, deploying the new ones, although like the main one is like the singleton one. So that's how, with this kind of logic, we are able to track and find the transactions that are literally the similar transactions, but to another contracts on the blockchain. And one of the things on the next screenshot is basically something that we are doing in order to do this thing. It's again like not the whole set, but we are showing here the example of the match call usage. It's also something that we do by parsing the ABI, and we are just checking that the signatures that are present in the transaction match to these ones. And so, for example, here we can see that there is like the function call at stake, and before that there is like the usual account abstraction calls, internal calls that mostly always should be present in this kind of transactions. So this here is just an example, but essentially you can do virtually everything here to, for example, track the similar order, or just to track like only some particular calls in the call stack. So here, that's how basically this kind of filter is working in order to enable us to produce only the similar transactions and like store them to the database. So that's pretty much it about the hackathon and how we did it there. And then the next slide is something that basically we're iterated on top already for bringing it to the production. So as we mentioned before, we're just using the Substream sync and like trying to push the data to our database. But then when bringing it to the production, we got to the point where we actually needed to store like more than one blockchain, to index more than one blockchain in order to find like the account abstraction transactions, similar transactions, and any other filtering like of the specific APIs that you can imagine. So we can, for example, we try to do it for the oracles, we try to do it for other things, but here we'll stop on this exact use case where we essentially are connecting to the Ethereum or Polygon or any other chain Firehose node, which already exists. And in our case, we only support the EVM, so it's like the 5 chains, in reflection, by the way, on the Optimism support now. So we have like the 5 chains now of which we can index, and that's what we do. So instead of just connecting to the Firehose node and streaming all of the blocks in our Node.js server before storing like the transactions there, we are now using the block like the substreams that I showed you later. That I showed you earlier, and we're packaging this code and this whole logic into one exact package, which then we are just using as the intermediary layer, which filters out only these things that we are interested in. So basically, we are initiating the stream from the Firehose node, but afterwards, this stream goes through the package that we built before. And then that's how we ensure that our block storage Substream sync, which is essentially just a Node.js server where we can virtually do any kind of logic before storing it to some database, or like probably using the message queues to send it to other services. We are receiving this stream, and this stream already contains not the blocks, but we are sure that it contains only the data that we need. And that's basically how like the substreams make their like main usage in our case, because basically they're allowing us to simply add this package and go to syncing the data only the one that is needed to the source of our trace. So the next slide will show you just a bit of this implementation, and then I hope that all the coding technical things will be mostly done. So yeah, this is just small examples for how we actually initialize the stream via the package. We can see that we load the package from our own repository, and then we read the registry in order to know how to actually work with the package. So how to decode the protocol definitions that we receive. And then we create the transport where we simply connect to the endpoint of Firehose, and then we are getting the current cursor just in order to keep iterating like only on the blocks that we haven't processed yet. And starting from this cursor, we just starting to consume the stream. And this part is shown on the next screen, I believe. Yeah, here, so we can see that basically we are consuming the stream just by going through the cursors and going through each block. So in the for loop, we just go through the response of the stream. And if we find that our output is actually defined, that means that our Substreams package produced some data. So there were like some transactions that of our interest in the block. And then if this output is defined, then we can actually insert it into the database or do anything you might imagine to sync it further in the pipeline. So that's pretty much it. And on the right here is a small example of the way how we choose what exact transactions we choose. So for example, here we are using the map combined transactions module output. That means that we are not only getting the account spectrum transactions, but also like the cumulative transactions. So we can actually define like the modules in our substreams to combine all the transactions, not to consume the blocks more than once, and actually just use different map modules to consume block once and then combine the results in order to process it further down the Substreams pipeline. So yeah, that's all of the boring parts with the technical details. And then the last thing is basically the table that we have. It's just something that is also being used now in the UI, but it's super simple for now, and it just does everything that is needed for the current needs. So we have the account transactions on the left. You can also see what we were experimenting with. We have like the similar transactions. We also do have the Oracle transactions. And we also have like the custom sync cursors, for example, in order to manage the cursors and the stream connection in our custom JavaScript sync. So that's how it's done there. And we will be working further on that in order to implement like more custom pipelines there to process any kind of data we need. But yeah, for now, like we have the option with account abstraction is like fully operational and it's already in production for you to test. So I think that's it.
Yes.
Hey.
That was maybe
That's
like
awesome.
technical, but please, if you have any questions, anything that we need to clarify, go back, please let us know.
Well, I have some questions. Just really, if I may, when you and your team, I guess anyone who wants to answer this from your team, first got introduced to Substreams, when was that? And what was that process like? Could you answer that?
Yeah. Arseny, want to take it? Should I take it?
Yeah, I can take it. So actually, first time we were introduced it was like, I think around 1 year ago. But at that point, we tried using it, and we found that it didn't fit the majority of our needs at that time. So, and also like it was a Rust code, a lot of Rust code, and we never had like any experience with Rust before. So that was like kind of the blocking point. And I would say we just tried it, maybe like played it with it for a couple of weeks and then just abandoned it for the better times. And that's why like we had some experience also, like we knew what Firehose is. I read a lot of documentation like previous year, like how exactly the stream and fast team is doing like this pretty efficient pipelines and like all the parallelization and substreams and everything. So like theory was kind of clear, but we couldn't really use it in practice. So then like already at the hackathon itself, which was like 2 months ago, that was like the second attempt at the Substreams for us. And that's where we actually found like the proper use case for this. And I also was like more ready to immerse myself into Rust to understand a bit better, like what exactly should I write and how to use the libraries there. And I think also like especially since the team also worked hard on this before, like we we saw that there were like many improvements, and there were like much more things we can actually start doing with Substreams. So that's pretty much
very cool.
answer if I help.
Very cool. So if other builders are out there looking to build with Substreams, what would you tell them to do? And also, why should they start building? Was attractive to you about Substreams once they learn the value?
I would say that, sorry.
Or Carson, yeah.
Is it one to ask? Okay.
No.
Yeah, so I would say, I would say like at least what was helpful for me is actually understanding like the lower level of how the whole thing works, especially the firehose and what is it and why exactly Substreams are working the way they are, because they are literally based on they're using the data produced by firehose, right? And for me, like for majority of like the previous year, firehose was something I understood like much better than Substreams, because we were working with the block data produced by firehose, and we tried to do some of the things that Substreams are doing now way more efficient. We were trying to do them like just by hand. Like we were trying to work with like this kind of raw data by ourselves. And that's why we understood like how exactly the block data is constructed and what is it. And then only after this part, I think it makes much more sense to look into the Substreams themselves to see how you can actually now work and transform this data way more efficiently. Because if you go straight from the Substreams, maybe also for the people who have much more experience with Rust, it will be much easier for them like to work with this directly without really knowing what firehose is. But in our exact case, it was easier first to understand like the data and like what is the data, how it's structured, and only then see how we applied the mappings of the Substreams on top of that.
Yeah,
that's great advice.
If I want to add to that, so one thing that's like more concrete, like what to look at that helped us is the protobuf files from Firehose. Those files are like the API of Firehose, and by looking at those files and seeing also the commands that the developers put like on each property, helped us actually understand like what type of data is being transported and how and where's the cursor and all of those mechanisms. They help us afterwards when working with the data, either in Substreams or outside of Substreams, to know like what data are we dealing with and how to deal with it pretty quickly. So
amazing. Yeah, I can understanding Firehose would be beneficial for that for sure. And then the protobufs getting that going. For builders out there, go ahead and learn Firehose to better understand, and then also protobufs understanding that kind of concept.
Yeah, and you don't have to run like a Firehose node. You can just use the public ones. They're good.
Yes, they are. Yes, shout out to the providers of those. Well, anyways, if there's any questions in the chat, feel free to post them now, and we'll be here for a little bit longer. But for now, I just want to thank the team, Arseni, Amin, and Tomas. Thank you so much for building Nazar. Super cool use of the Substreams technology. Congratulations on your win. And I wish you a lot of more happy building with BlockTorch and seeing where that push with Substreams can go. I'm curious about that myself. So
much. Yeah, more things are coming. Yeah.
Awesome. If you want to put any links in the chat, feel free to put links in the chat for anyone to follow, and they can go ahead and reach out to you, maybe your Twitter, and then maybe anything else that you'd like to support for BlockTorch. We'd love to support what you're building.
Yeah, or
Awesome. Well, thank you guys for joining. Thank you for enjoying another Graph Builders Office Hours with Nazar, team behind Nazar, and we'll see you guys in the next Graph Builders Office Hours. Take care, everyone.
Thank you so much. Thank you. Goodbye.
Right. You guys are welcome to stay here if you want. We'll just end the record. Great, awesome work with that. I think having a year of just kind of understanding at a distance of what Substreams are, and then having this hackathon really, that's a big advantage too. It's to kind of understand what Substreams are doing, and then from there, then a dedicated hackathon. That must have been a lot of fun.
Yeah, like we did quite a lot of things like during that year, but then coming back to the Substreams at some point, yeah, it was like actually interesting to see like the progress made by both us and the Substreams instrumentarians.
Yeah, and the help from the Substreams team was really amazing. So we were going to them and telling them about these crazy ideas. We want to do this and this and this and that, and it was like, wait a second, okay, and they think with us, and it helped us a lot as well, like to go through it.
Yeah, I was super bummed I missed it. I really did want to go. Maybe next one that's in Istanbul. Hopefully it's in Istanbul. I know they just announced ETHGlobal. It's not going to be in Istanbul this year, but I've always wanted to go. I missed out.
Yeah.
But anyways, thank you guys so much for your time. Like really, really appreciate your time, and keep on building, and have a good one, everyone. Thank you for joining.
Thank you.